Hello again, higher algebra students, back here with lesson 4 of Unit 12, which is reflecting exponentials. So goal here is really, again, to be able to describe and graph these reflected exponentials and then to be able to transform them with both translations and reflections. So looking at this, what we have really are two different scenarios. And again, we've talked about these reflections in the scenario of when the negative is applied directly to the x or when the negative is applied out front. And again, when we think about reflections on a coordinate grid, if we have a graph that's up in the top right here, say an exponential growth, what we're looking at is either a reflection over the x-axis, which would be the negative out front, or the reflection over the y-axis, which would be the negative right with the x. So for instance, this first one would be a reflection over the y-axis. So that would be what's called a horizontal reflection. And then the one with the negative out front would be a reflection over the x-axis, which would be a vertical reflection. So again, when we look at this third one here, the negative is in front of the x, so that would be a horizontal reflection. Because of where the negative is, it's like the first one there. And then the last one here has the negative out front, which means these two are similar, so this would be a vertical reflection. Okay, let's jump into some actual graphs here. So this 3 to the x, again, the original 3 to the x graph, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9. So this is actually the original 3 to the x graph. Now, the horizontal asymptote, again, would be at y equals 0. Again, that's the default unless there's a vertical translation. So with this negative just in front of the x, this should be a horizontal reflection. So I'll switch colors here. Again, we'll just use 0, negative 1, and 1 again. So 3 to the negative 1 is really 3 to the 1. So this would be 3 now. 0, 0 or negative 0 is still 1. And then 1 here, so this would be 3 to the negative 1, which would be 1/3. So what we have in the blue graph then is that the value at 1 is 1/3. 0 is still at 1 because, again, that's right where it's reflecting over. It's reflecting right over the y-axis here. And so that's actually on the reflection line, so that didn't change. And then negative 1 goes to the 3. And then, again, negative 2 here would go to that 9. So what we've got on the new graph is the same sort of thing. It looks like an exponential decay now. But we've got this reflection over the y-axis here. And with that reflection, we still have the y equals 0 asymptote, the horizontal asymptote there. But you can see the reflection over this axis right here. So that would be 3 to the negative x. Here's another one with the negative out front now. So with the negative out front, what we can expect to have happen is a vertical reflection going over the x-axis. I'll make it a little bigger here. So with the x being just left alone, I'm going to use 0, negative 1, and 1 again. And what we'd have then is a negative 2 to the negative 1, a negative 2 to the 0, and a negative, sorry about that, a negative 2 to the 1. Well, 2 to the negative 1 is 1/2. Again, so this would be negative 1 over 2 to the 1. And that would be just a negative 1/2. So negative 1, negative 1/2. 0, well, that'd be a negative 1. So that's a negative 1. And 2 to the 1 is 2, and then make that a negative. That's a negative 2. So we've got 0, negative 1, and 1, negative 2. If we were to put a 2 there, 2 squared, and then make that a negative, that'd be negative 4. If we put a 3, 2 to the 8, or 2 to the third is 8, and make it a negative, so that'd be a negative 8. So here's our graph. Again, there is no vertical translation here, so this is still y equals 0 for the asymptote. And our graph would then look like this. So again, it almost is like we're decaying again, but the original graph here, 2 to the x, what would have been the original, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8, even 2 to the negative 1 is 1/2 there. So this was the original graph, and you can see that reflection over the x-axis, which is a vertical reflection here. So this would be a vertical reflection. Okay, continuing on. 1/4 to the negative x, so now the negative is applied directly to the x again, so we can expect a horizontal reflection here. I might have said translation on the last slide. These are reflections. Again, so if I had the original graph, which I'll do in red again, would be 1/4 to the x, so 1/4 to the 0 is 1, 1/4 to the 1 is 1/4, 1/4 to the negative 1 is 4, and so on. So this would be the original graph, a little exponential decay there. Again, there is no vertical translation, so our asymptote is still at y equals 0. Now, the 1/4 to the negative x, again, being this horizontal or reflection over the y-axis here, if I put -1, 0, and 1 in there, so now if I apply this to the new equation, if I have 1/4 raised to the -1, again, the x here is negative, but there's also a negative in front of that, so that's why we have the negative in front and the x being negative. So that would just be 1/4 to the 1, which is then 1/4. So here we've got -1, 1/4. 0, again, 1/4 to the 0, or -0, or -0, whatever it happens to be, that's just going to be 1. That's, again, on our reflection line. And then 1/4 to the -1, well, that's 1/1/4, which is 4. So we've got the point 1/4. So our new graph would look like this. And again, you can see that reflection over the y-axis. This one here, got the negative out front. So the original graph, which would have been 1/2 to the x, well, that means 1/2 to the 0 would have been 1. 1/2 to the 1 would have been 1/2. 1/2 to the -1 would have actually been 2. 1/2 to the -2 would have been 4, and so on. Because that would have been 1 over 1/2 squared would have been the 4. So this would have been the original graph here, an exponential decay, again with an asymptote at y equals 0, because that's, again, not translated up or down. So now our new graph, if I put in -1, 0, and 1, so our new graph would be negative, and then 1/2 to the -1. 1/2 to the -1 is, this would be -1/1/2, which would be equal to a -2. So let me change colors here. So we'd have the point -1, -2, which would be right there. 0 again, 1/2 to the 0 is 1, make that a -1. Okay, so 1/2 to the 0. But then we also have the negative out front, so that would be a -1. And then 1/2 to the 1 is 1/2, make that a negative, so that's -1/2. This would be -1/2. And again, put that same asymptote. You can see the reflection over the x-axis here. So put these together now, translations and reflections. So this is a graph where the original one would have been 2 to the x. Okay, so 2 to the x, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the -1 is 1/2, 2 squared is 4, 2 to the third is 8. So this is the original graph, which again has its horizontal asymptote at y equals 0, and so on. You can see we do not move this up or down at all, so the asymptote should stay at y equals 0. But now, if I actually provide what we've got here is a negative out front, so that should be a vertical vertical reflection. But then we've got x plus 7, so this should be 7 units to the left. So what we should do here is actually vertical reflection, so turn this over to the bottom, and then move it 7 units left after we turn it over to the bottom. So again, The way I like to set up the table here is what makes the exponent be 0? Well, that'd be negative 7 plus 7 would make the exponent be 0. So I'm going to use negative 8, negative 7, and negative 6 here. So if I put a negative 8 in there, so that would be negative 2, and a negative 8 plus 7 is negative 1. So it'd be a negative 2 to the negative 1, which is a negative 1 over 2. So this would be negative 1/2. If I put a negative 7 in there, well, that would be negative 7 plus 7, which is 0. 2 to the 0 is 1. But then a negative out front means that's a negative 1. And then finally, I put a 6 there. So that'd be a negative 2. And again, when I put a negative 6 in there, negative 6 plus 7 is 1. So it'd be a negative 2 to the first. Well, 2 to the first is 2. Make that a negative, so that would be negative 2. So I would have the points negative 8, negative 1/2. Negative 7, negative 1, and negative 6, negative 2. So again, we've got our asymptote here, and this is just going to continue going down like that. So what we did again is we took this graph, we reflected it over the x-axis, and then shoved it 7 units to the left. And you can see that, for instance, if you look at this point right here, this would have gone reflection over the axis, and then 1, 2, 3, 4, 5, 6, 7 units to the left. Here's another one. Now this one, the original graph was 3 to the x, so the original graph went 1/3. 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. So here's the original graph. But now we are going down 4 units. So our new asymptote here should be at y equals negative 4. And again, this negative x means it should be a horizontal horizontal reflection, or reflection over that y-axis. So we don't influence the exponent except for making it negative. So I'm going to use negative 1, 0, and 1 here. And if I put in 3 to the negative 1, again, the x is negative 1, and there's the negative out front. So there's a couple negatives there. So that'd be 3 to the 1, which is 3, and then minus 4, which makes it a negative 1. So I'd have the point negative 1, negative 1. 0, again, 3 to the 0 or 3 to the negative 0. Either way, it's 1. 1 minus 4 is negative 3. And then if I put a 1 in there, 3 to the negative 1, well, that's 1/3. 1/3 minus 4 would be negative 3 2/3, or negative 3.67. So that would look like this. Oops. Just realized that I had put that at negative 4 instead of negative, or excuse me, yeah, negative 4 instead of negative 3. So let's do a quick erase on this and put that at negative 3. And then this is negative 3.67. And if I continue on here, again, if I went to negative 2, so that'd be 3 to the negative 2. Well, that's 3 squared is 9. 9 minus 4 is 5. So that gives me just a little more of a picture of what's going to happen here. So it ends up looking like this. Again, my asymptote here would be right here, where I'd actually put that dot that you're probably looking at saying I put in the wrong spot the whole time. And so now I've got my horizontal reflection. Change colors here quickly. Horizontal reflection. And I've moved it down 4 units. So for instance, this point was reflected right over to here, and then down 4. All right. Here's another example that has a lot going on. So we've got, first of all, the negative out front. We also have an x minus 2 in the exponent, and we've got a plus 4. So there's really, this is a reflection here, so this would be a vertical reflection because the negative's out front. This would be 2 units to the right because of that minus 2, and again, I'm going to make sure that my middle term in my table is a 2, because 2 minus 2 would make that 0. And then that plus 4 would be a vertical translation. They go up 4 here. So I'm going to use 1, 2, and 3 here. Again, the original asymptote would be at y equals 0. The original graph of y equals 1/3 to the x. So if we had a 0, that would still be 1. If we had a 1, that'd be 1/3. If we had a -1, that'd be 3. So the original graph looks something like this. But now we're going to switch that over. We'll do this in blue here. So if I put a 1 in there, so if I have negative 1/3 to the 1 minus 2 and then plus 4, 1/3 to the -1 would be 3, because that's 1/3 to the -1, which is 1 over 1/3, which is equal to 3. So it'd be 3, but it's a -3, and then plus 4, so that would actually be the point 1, 1. So 1, 1 is a point here. If I put 2 in there, then that would be 1/3 to the 0, which is 1, but then a -1 because the negative's out front. So -1 plus 4 is 3. And if I put a 3 in there, that would be 1/3, if this were a 3 here, 1/3 to the 1, which is 1/3, -1/3 because of the negative out front. So -1/3 plus 4 would be actually 3.67, or 3 2/3. So that would be 2, 3, and then 3 2/3. And what's going to happen is, because of the plus 4, I do have a horizontal asymptote here at y equals 4. So what ended up happening here is, because of the vertical reflection, the asymptote, rather than being at the bottom like it was on this red one, is now at the top. Again, if I were to put 0 into this equation, that would give me a -2. I'd actually have 9, but it'd be a -9 plus 4, so it'd be a -5. So it actually looks like this. Again, it can be kind of hard to tell, even after 3 points, where this thing rounds off at. But having the asymptote in there helps to show us, okay, we can't get up to that line y equals 4. So we know that it's really bailing at the bottom, that it's going more vertical at the bottom and more horizontal here at the top, as this is going to keep going out like that horizontally. So what we had here is a vertical reflection, and then we moved it right 2, and then we moved it up 4. So a lot going on there, but that would be our translation there. And we'll end with one more here. And on this one, again, we have the vertical reflection. We also have a horizontal reflection, and then a plus 1. So we've got double reflection here. So if I put 0 and -1 and 1 in, so I've got 1/4 to the -1. And then I've got the negative out front. This is a lot to deal with. So again, this is x equals -1 here. So I have a 1/4 to the 1 is 1/4. A negative there makes it -1/4. And then I add 1, so -1/4 plus 1 is 3/4, or 0.75. If I put a 0 in there, -0, it's either way, it's still 0, so 1/4 to the 0 is 1. And then I put the negative out front, that's -1, and then I add 1, and there's 0. And then 1, if I have 1/4 to the -1, well, that would be 4. I put the negative out front, that's -4. -4 plus 1 is -3. Now my asymptote here, and I won't draw the original on this one, this is already going to be busy, so my asymptote is at y equals 1, because again it's 0 originally, but I'm moving this up 1. So there's my asymptote. I do have the point -1, 3/4, 0, 0. 1, -3. You can see if I put a 2 in there, this is going to be way down here, so it actually ends up looking something, oh, sorry, I missed it there, like that on this one. So it's a very unique graph, again, where we basically have rotated our original exponential decay graph. So again, 1/4 to the x just in general would look something like this. And what we've done is we've kind of rotated that, even though it's difficult to see. But you can see kind of the part that bends a little more sharply is right there. And we've rotated this around, and instead of bailing out at the top, it now bails out at the bottom. But again, this would be a horizontal reflection, a vertical reflection, and moving it up 1. And again, vertical here, horizontal here, and then up 1 here. So in the end, when we look at this, we really want to know the difference between a translation and a reflection. Can translation just slide something up, down, left, or right? Reflection is going to turn it over. Able to translate an exponential all 4 directions there. Are you able to reflect an exponential over the x and the y, which again is the negative out front, or is the negative within the parentheses there? And are you able to graph a combination of these translations and reflections, which was those last couple of slides? So thank you as always for watching. If you have any questions, please ask.